Alright, so our second video is going to all be about the different vocabulary that we need to know for this unit for transformations, and we're going to add to this each video, but this is just some of the basics that kind of cover the entire unit of transformations. So we want to be able to define what a transformation is, talk about its image and its pre-image, define a rigid motion, and identify corresponding parts. I'm going to tell you now that these two things right here, super important, come up all the time as multiple choice questions and as part twos. All right, so a transformation is a mathematical operation performed on a figure that changes its position, size, or shape. So we're going to learn about 4 of them. All right, it's going to be reflection, rotation, translation, and dilation. All right, those are the 4 different transformations that we're going to talk about. Dilations is going to come up in a later unit, but these are the big 3 that we're going to learn about in this unit. All right, so let's just get to the next word here. Pre-image, a figure or point before the transformation takes place. It can also be called the object. So for example, if I start with a triangle here of A, B, C, and I reflect it over this line, and it becomes A prime, B prime, C prime, this is the pre-image because it's what we're performing the transformation to. This is afterwards. So this original triangle is considered our pre-image. All right. So if I use that same example for the second one, or for the next vocabulary word where it says image, that's the figure after the transformation takes place. So again, if I have the same picture, A, B, C, and I reflect it over this line, which is something that we'll talk about in video 3, how to do reflections and what that really means. That means this figure is going to be the image because it's what happens afterwards. Okay, so when we talk image and pre-image, you'll start to see when we do some graphs and some actual reflections and rotations what this actually looks like in a question. All right, the last 2 vocabulary words are probably the most important, as I highlighted above. A rigid motion is a transformation that preserves distance and angle measure. Basically means it does not change size or shape, okay? Or it produces a congruent figure. Those are super, super important things that we need to know. You have to memorize this. So there are 3 rigid motions that we are learning about, which is what this entire unit is about. You must know that a reflection is a rigid motion, that a translation is a rigid motion, and that a rotation is a rigid motion. Because all 3 of these just move the object or the image. They don't change how big it is. They don't change the shape of it. All they do is move it to a new place. All right? So rigid motion, important definition. Please memorize it. Please understand it. If you don't, ask questions. All right? Correspondence, our last vocabulary word here. It's a point, side, or an angle that are in the same spot in 2 different shapes. So, for example, if I have a triangle here, let's call it A, B, and C, and I just kind of slide this figure to the right, and I make a new figure called D, E, F. The corresponding parts, or the correspondence, is the pieces that line up with one another. So in this case, A lines up with D, B lines up with E, and C lines up with F. You'll see that in one of the questions below when I go over it as an example, and you'll kind of start to understand the difference. So, Regents question number 1. The vertices of triangle JKL have coordinates of J, K, and L. Under which transformation is the image JKL not congruent? So basically this means which one of these 4 choices is not a rigid motion. So as we went over above in the vocabulary, the only one here that is not a rigid motion is a dilation. You can think about that as if we were thinking when you go to the doctor, your pupils dilate, so they get bigger and smaller. A dilation here is the only one that is not a rigid motion. Remember, a translation, a rotation, and a reflection are all examples of rigid motion. So when it says not congruent, we are looking for ones that are not going to change the size and shape. All right, so a dilation changes the size and shape, therefore it's not a rigid motion, so that's going to be our answer. Okay, our second example, we have triangle XYZ and ABC. So XYZ is the image of ABC after the rotation. So since XYZ is the image, this is our starting point. So we start with ABC and we get to XYZ. So whenever you see something like this, the first thing that I like to do is I like to stack my letters on top of each other so I know which parts are supposed to line up with one another. So what we're going to have here is we have 6 pieces because all these triangles are made up of 3 sides and 3 angles. So because I stacked these on top of each other, it helps me figure out which sides line up with one another. So because the A is on top of the X, the B is on top of the Y, and the C is on top of the Z, that tells me that angle A is congruent or corresponds to angle X. Angle B corresponds to angle Y, and angle C corresponds to angle Z. Now, I can use the congruent sign because when we said before, since it's a rotation, it's a rigid motion, so therefore everything in ABC is going to be the same in XYZ, so I don't have to worry if they're different sizes because I know they're not because a rotation took place. Now, the sides. So when we talk about the sides, what I just like to do, I just like to go by the letters. So A to B is going to match up with X to Y. So I can say A to B is congruent to X to Y. And you can always highlight them on the picture if you'd like. All right, the next one I would do would be B to C and Y to Z. B to C is congruent to Y to Z. And then lastly, the only 2-letter combination I have left is A to C and X to Z. And again, those are all the same for the same reason, because a rotation does not change size or shape. So all 6 of these pieces of information are going to be the same. All right, so those are corresponding parts. All right, one more question. The image of ABC after a rotation of 90 degrees clockwise about the origin is triangle DEF as shown below. So which statement is true? So we know that they're all congruent because remember, a rotation is a rigid motion. So we want to figure out which pieces here correspond to one another. Now, we could try to overlap the triangles and kind of trace them on top, but I think that's a little bit harder to visualize. What I like to do, as we did in the example before, I like to list ABC on top of DEF, because if they write them like that in the question, then those are the parts that correspond with one another. So if we look, this is kind of, I just go through the choice here. Does B to C correspond with D to E? Now, does B to C correspond with D to E? And I would say no, because B doesn't line up with E. B doesn't line up with D here, and C doesn't line up with E. This is not the right choice. Now, the next one I would do the same thing. A to B and D to F. Again, I would also say no. Although A does line up with D, B does not line up with F, so those are not going to be the corresponding sides. They don't line up with one another. So that's incorrect. The next one would be angle C and angle E. Well, angle C and angle E definitely do not line up because they're not stacked on top of each other. And that leaves me with my last choice, which is A and D. And we know that A and D line up with one another because that's how I drew out my letters. So that has to be the correct answer. So we have A. Angle A is congruent to angle D. Right? So these questions, make sure that if they list you A, B, C in order, you list D, E, F in order, one right on top of the other, and that's going to tell you which parts correspond with the others. That's the easiest way to figure this stuff out. All right, so get to the practice problems on the bottom, write down any questions that you have, and after this video, after you're finished the practice for this video, this is going to be your first mastery check for this unit. All right, so let me know when you're ready for that, and when you get 4 out of 5 on that, I'll see you for video 3.